Okay, so for problem one over here, we're given this function f of x equals x cubed plus x plus 1, and we want to just find the difference quotient of this. So let's do that. So we're going to need to compute what f of x plus h is. Okay, so we're going to be plugging that into our f of x function. So it's going to be x plus h in parentheses cubed plus x plus h plus 1. Use parentheses, they're your friend, right? Yeah, they'll help you keep you from doing algebra mistakes. Now, x plus h cubed is somewhat complicated, okay? That's x plus h times x plus h times x plus h, right? The rest of this, though, that's just adding on x plus h plus 1, so that's no problem. So this part right over here, though, it might give us a little bit of concern. So here's what we're going to do. We're going to FOIL it out, starting out with just these two, okay? So we're going to FOIL that part out first. And when we do that, we get x squared plus 2xh plus h squared, right? But we still have this other copy of x plus h here, okay, that we have to deal with, okay? And then now we can FOIL these ones out, right? So it's just the same thing as before. We do first times first, first times second, right? And then we can do second times first, second times second. And then we can do third times first, third times second, right? So we're going to get x squared times x, which is x cubed, plus, oh, I'll put parentheses around this for now. And then we're going to do x squared times h, so that's going to be a plus an x squared h, plus, now we have a 2xh times x, so that's going to be plus a 2x squared h. And then we're going to have 2xh times h, so it's going to be a plus 2xh squared. And then we have plus a h squared times x, so I'll write that as xh squared, plus h squared times h, which is h cubed, right? Any questions on that? Mhm. Yeah, I'll post this online as soon as I can. It might be up tomorrow morning, something like that. Yeah, okay. All right, so then now I can simplify this, right? Combine like terms. I have an x cubed over here. Okay, good. I have an x squared h plus another 2x squared h, so that makes 3 copies of x squared h. Okay. I have a 2xh squared plus another xh squared, so that makes 3 copies of xh squared, and then plus h cubed plus x plus h plus 1, right? And there are no other like terms to combine together, right? All right, so that's f of x plus h, which is just this part of the difference quotient, right? Okay. So now I'm going to compute what f of x plus h minus f of x is. Okay. F of x plus h minus f of x. Well, we know what f of x plus h is. We just computed it. So that's x cubed plus 3x squared h plus 3xh squared plus h cubed. And then now we're subtracting off f of x, which is just x. Oh, sorry, I left off part of this one. Plus x plus h plus 1. Okay. And then now we're subtracting off f of x, which is just an x cubed plus x plus 1. So let's see what kind of like terms cancel off here. Our 1's cancel off, our x's cancel off, and our x cubes cancel off, right? So you should always get a lot of cancellation, right? And a good check to see whether you did it right, right? It's not 100%, but a good check is if you're only left with terms that have h in it, right? That's probably a pretty good sign you did it correctly. Okay. So here you can see this term has an h in it, this term has an h in it, and this term has an h in it. Okay. So I'm just going to simplify this now. It's just 3x squared h plus 3x h squared plus h cubed. Okay. So that's what f of x plus h minus f of x is. And then now to complete the difference quotient, we have to take that as our numerator and divide it by h, right? So f of x plus h minus f of x divided by h. This will be my difference quotient now. That's just going to be 3x squared h plus 3x h squared plus h cubed divided by h, right? And we have to simplify this as much as possible. Okay, but the only way that we can cancel something in the denominator with something in the numerator is if we have common factors. So we're going to have to factor, right? So up top over here, I see that I can pull out an h from all 3 of these terms. So I get h times 3x squared plus 3xh plus h squared, right? And that's all divided by h. Now I have a common factor between the numerator and the denominator, so they can cancel off. So I'm just left with 3x squared plus 3xh plus h squared. And that is my difference quotient for that function. Okay. For those of you going on into calculus, you're going to do a lot of this. So I'll pause here. Are there any questions? Yeah, if you have any, just shout them out. Scroll up. Yeah. So you had a problem like this on your active engagement assignment that you turned in on Thursday, right? And so I had it broken down into parts A, B, and C, right? But I'm leaving that off of the test, right? So like, so you just have to remember what parts A, B, and C were. They were exactly what I showed over here, though. So, all right. All right. So I'm going to go ahead and move on to problem 2 here. Okay. Where we're finding the average rate of change of this function over the interval 0 to 2, right? So, so I gave you the formula for the average rate of change over here, just in case you forgot, right? Yeah. So remember this interval that I give you, these are the x values, x1 and x2, like so. All right. So all we have to do is just plug it into the formula, right? So I'll go ahead and compute what f of x1 is, right? So f of x1, right? Well, my x1 is 0, so it's just f of 0. So I'm plugging 0 into this function, and I'm just going to get 1. Okay. F of x2, right? That's my second x value, which is 2. So it's f of 2. So I'm plugging 2 into this function, and I get 8 plus 2 is 10, plus 1 is 11, right? Okay. So that's f of x1, that's f of x2, right? So then now we can get on to computing the average rate of change here. Okay. So my f of x2 was 11, right? My f of x1 was just 1. My x2 was 2. My x1 was 1. So I'm going to get this as 10 over 1, which is just 10, right? Easy, right? Any questions on that? Any questions on that at all? So the x1 is 0. The x2 is 2. Right? So here is where I've used f of x1, right? And then in the formula over here, f of x1 appears, right? Here's where I do f of x2, and then in the formula, f of x2 appears as well. The denominator? Right, so that's x2 minus x1. Oh, my x1 was 0. I see what you're saying. Okay. Yeah, my x1 was 0. Sorry, everybody. Here, I'll put it in red for where I'm correcting it. Yeah, my x1 was 0. I thought it was 1. My mistake. Okay, so then this is actually 10 divided by 2, which is 5. Okay, that's a lot better. Thank you. Yeah. Mhm. Oh, so I actually plugged 2 into the function, right? Yeah, so I get 8 plus 2 is 10 plus 1 is 11, right? Yeah. Okay. All right, so let's move on to problem 3 then. Okay, so now we have f of x equals the square root of x squared minus the absolute value of x. And I want to know, is this function even? Is it odd? Is it neither? Right? So in order to receive credit, you have to actually use the definition of even or odd, right? No, don't just look at the graph and say, oh, it has this kind of symmetry, so therefore it's an even function or it's an odd function, right? You actually have to prove that it is even or odd from the definition, right? So as a little reminder over here, and I don't expect you to write this on the exam, so let me go ahead and put it in a different color here, right? The definition of even is that f of negative x simplifies it to be the same thing as f of x. Yeah. And the definition of odd is that f of negative x simplifies to just be negative f of x. Like you can factor a negative out of all the terms, basically. Yeah. Okay. So that's what we're working with here, right? We're trying to see if f of x satisfies this definition or neither, right? Because it's possible for a function to be neither even nor odd. Okay. So let's see. I'm going to compute f of negative x, see what we get. Okay. So f of negative x will be the square root of, well, my x is being squared on the inside. So this is going to be a negative x being squared instead. Okay. Minus the absolute value of negative x. Okay. All right, just replacing x with negative x everywhere. Any questions on that? Okay. All right. So then now, right, so let's simplify that. So we have the square root of negative x squared. Okay. So this is the same thing as negative x times negative x, which is going to be a positive x squared on the inside. All right. So that's just the square root of x squared. Right. Okay. Minus, well, the absolute value of negative x is exactly the same thing as the absolute value of x, right? Yeah. Whether x is positive or negative, right? The absolute value bar is going to ignore that. Okay. So then we have that this is the square root of x squared minus the absolute value of x. Okay. But this is exactly what f of x is. It's the square root of x squared minus the absolute value of x. So we have just shown that f of negative x is equal to f of x, right? So f of x is even. Don't forget to, say something, conclude something. Yeah, after you're done, you got to say, so f of x is even, so that I know that you know that it's even, right? You know that you have just shown that it is an even function, right? If you left this part off, right, then, well, what have you shown me, really, right? I don't know. You just showed me some algebra, right? But what does it mean? Yeah, so this part is absolutely necessary. That's that final sentence there, okay? Fair enough. You know what? Let's just go even easier than that. You don't have to say all that. You could just say even afterwards, and that's perfectly fine with me. Yeah. Okay. Fair enough. But I do need to see some kind of conclusion there. All right. Any questions on that? Okay. So, yeah, I'm talking about the real exam now, right? So the questions on the real exam are going to be very similar to the questions on this, right? Yeah, so the function that I give you, though, it could be an even function, it could be an odd function, it could be neither, right? So just be aware of that. Yeah. Okay. Okay. So now intervals where we're increasing or decreasing, right? So I give you a graph like this one, right? And so the first question is on where are we increasing, right? So let's just go ahead and draw all the places where we're increasing. I'm just going to trace them on the graph here in blue, let's say. Okay. So we're increasing here, right? Because as we go from left to right, our y values are getting bigger, right? We're increasing here. Okay. And that's about it, right? Everywhere else is decreasing, yeah, or staying the same, right? So, on what intervals is f of x increasing? Well, remember that when we're talking about the intervals, we're talking about what are the x values that we see, where the y values are increasing, right? The x values. So between x equals -4 and x equals -3, our y values are getting bigger. So we would say that it's increasing on the open interval from -4 to -3, not the closed interval. We don't do closed intervals for increasing or decreasing. It's technically impossible for you to be increasing at a single point, basically. So that's why it's always open intervals. Yeah. Okay. So -4 to -3. And then also, as for x's between -2 and 0, we have our y values are increasing, right? So -2 to 0. Okay. Remember, these are the x values, right? So any questions on that? Okay. So now we got to do the decreasing part, right? So maybe I'll trace that in purple here. Okay, so it's definitely decreasing here. Okay. All right, staying constant over here, but it's decreasing starting from here all the way out to here, right? That's all one continuous interval there where it's decreasing, okay? So keep that in mind. When we say that what intervals are we decreasing? Well, for x's between -3 and -2, we have that as decreasing, right? But also for x's between 1 and 4, we have that as decreasing, okay? So it would be wrong to say, well, the interval from 1 to 2, union the interval from 2 to 3, union the interval from 3 to 4. Yeah, that would be wrong to say that because that's not quite the same thing as the interval from 1 to 4. Okay, yeah, we're leaving off x equals 2 and x equals 3 if we do that, right? So let me just write down what's wrong here in red, okay? So it would be wrong to say -3 to -2, union 1 to 2, union 2 to 3, union 3 to 4, okay? Right? Our interval should include 2 and 3, basically. So this is wrong. Okay. probably take a point off. Yeah. Okay. All right. Any questions on that? Yeah. What was that? If you separate them with commas, that's fine with me, I guess. Yeah, that's fine. Yeah. It's just there's a lot of commas running around, so it gets kind of cluttered, right? Maybe if you put just a little space between the intervals, I guess it'd be fine. Or you could just say this interval or this interval, something like that. Okay. All right, so now we're going to do local maximums. So let me scroll up to the graph over here. Where are their local maximums? Let's circle them in black, right? That's a local maximum, right? That's the largest y value in some small window there, right? It's bigger than all the y values around it, right? This is not a local maximum right over here or over here, right? And those are not local maximums because they're not the largest y value, right? They have to be larger than everything to the left of it and everything to the right of it, right, in some small window. Yeah. Okay, but clearly you see that the same y value over here, right? Okay. And then that's it, right? So this is the only local maximum, right? And so I'm asking specifically for the x value of any local maximums. Sometimes some textbooks, some problems in MyLab Math might say the location of a local maximum, right? So this x value is also sometimes called the location. Okay. So this local maximum happens at x equals -3, right? So I'll say x equals -3. Okay. Any questions on that? No. Okay. Let's do local minimums then. Okay, local minimums. This is clearly a local minimum, right? And then that's it, right? Yeah, so we have x equals -2 is the location of a local minimum. All right. So any questions on that? All right, on to the next one. So this one has to do with parallel and perpendicular lines, right? So we have y equals -1/2 x minus 4, and we want to find the equation of the line, right? That's parallel to this, passing through the given point, right? And we want it to be an oh, I didn't say this here. I wrote it on the actual exam though, so let me go ahead and write this in over here. Final answer should be given in oh yeah, okay, I did write it over here. Slope intercept form. Yeah, that's what I want. I wanted to be in slope intercept form. My mistake. Yeah. Okay. So let's do this then, right? How much work do we really need to show here? Well, we're talking about a line that's parallel to this line. So we already know that the slope is going to be the same slope, right? Fair enough. Just write down what the slope is. M equals -1/2, right? Okay. And then we have this point over here, right? -1, 1. That's my x1 and my y1. Okay. Fair enough. And then now you do the point slope form of a line, which is y minus y1 equals m times x minus x1, right? So that's going to be y minus 1 is equal to -1/2 x plus 1, right? Minus -1, maybe plus 1. Okay. And then now we just solve for y, and that'll be in slope intercept form when we solve for y. So we get y is going to be a -1/2 x minus 1/2, but then plus 1 makes this a plus 1/2, right? All right, questions on that? Any questions on that? Okay. Well, now that we have that then, right? Now we're going to do the same thing with perpendicular lines, right? So with perpendicular lines, remember that the slope is going to be the negative reciprocal. So we got to take the negative of this number, which will be +1/2, but then we got to flip it, right? So it'll be +2, okay? Negative reciprocal, okay? Still have the same point there, right? -1, 1 is our x1, y1, okay? So we're going to do the point slope form of the line. Y minus y1 equals m times x minus x1. And just plug everything in. So y minus 1 equals 2 times x minus -1, so x plus 1. Okay. And then we'll just solve for y. Y equals 2x plus 2 plus 1 is plus 3. Okay. And there we have it. So any questions on that? Any questions at all? All right, good. Well then, on to the next one. Solve the equation that is quadratic in form, right? So quadratic in form means it's not a quadratic equation, but we might be able to do some kind of variable substitution to turn it into a quadratic equation, right? Okay. So the trick here is, well, we have an x to the sixth minus 64, right? Okay, so usually when we see equations that are quadratic in form, right, we would see something like this, an a times x to the sixth power plus a b times x cubed plus a c is equal to 0, something like that, right? Yeah, but there's no x cubed term in here, right? But you could put one in if you want to, right? So this is the same thing as x to the sixth plus 0 x cubed, right? Coefficient is 0, right? Minus 64 equals 0. Yeah. So you could insert that term if you need to. Um, Not necessary though, because we're just going to wind up letting t be equal to x cubed, right? And when we do that, that means that t squared must be equal to x to the sixth power, right? So as long as you remember that this is supposed to be your t squared term, you should be fine. Okay. So when we do the substitution, now we're going to have t squared minus 64 is equal to 0, right? Which can totally be factored, right? This is a difference of squares formula. So t minus 8 times t plus 8 is equal to 0. You could solve it that way. You could also solve it using the square root property, right? Add 64 to both sides, then take the square root. You get t is equal to plus or minus 8, right? Or you could do it using the quadratic formula, right? Don't forget the quadratic formula. Remember that, right? So it's negative b plus or minus the square root of b squared minus 4ac over 2a, right? Yeah, so you can do it any way you want to, right? But now you get two answers. You get t equals 8, or you get t equals negative 8, right? Fair enough. Okay. All right. And you know what? The great thing about factoring is I could write this. T minus 8 is equal to 0, or t plus 8 is equal to 0, right? Yeah, so either this term is equal to 0 or that term is equal to 0, right? So we can just start off that way, right? And then now we have t is equal to x cubed. So this is the same thing as saying that x cubed minus 8 is equal to 0. And this is the same thing as saying x cubed plus 8 is equal to 0, right? And so now we have a difference of cubes, right? Which can totally be factored, right? So just as a little reminder over here, I'll have a little aside, right? The difference of cubes formula and the sum of cubes formula, right? If we have an a cubed, well, I'll do minus a b cubed first. A cubed minus b cubed factors as a minus b times a squared plus ab plus b squared, okay? A cubed plus b cubed factors as a plus b times a squared minus ab plus b squared. Okay, fair enough. So we're going to get pretty similar factorizations here. Okay, so we have x cubed minus 8. So a would be equal to x, right? B would be whatever the cube root of 8 is, which would just be 2, right? So this is going to factor as x minus 2 times x squared plus 2x plus 4, and that's going to be equal to 0, right? Okay. This one over here, very similarly, it's going to be x plus 2 instead, times x squared minus 2x plus 4 is equal to 0. Okay. All right, and then now we got to solve this. So we get x equals 2 is one of our solutions, but we also get x squared plus 2x plus 4 equals 0, right? And so we got to solve that using the quadratic formula because these are going to give us complex roots in this case, okay? So x is going to be equal to negative 2 plus or minus the square root of 4 minus 16 all over 2, right? Just using my quadratic formula there, which let me do a little aside over here so you can write it down. A quadratic formula, all right, if we're looking at ax squared plus bx plus c is equal to 0, then we have x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? All right, so now to simplify this, we got negative 2 plus or minus the square root of negative 12, right? So that's going to be a 2 square root of 3i, right? All divided by 2. So this is going to be a negative 1 plus or minus the square root of 3i. Okay. Okay, so that's my solutions that I get from this one, right? So just to write them all out in a list here, it's 2, negative 1 plus the square root of 3i, and negative 1 minus the square root of 3i. So that's 3 solutions, right? Okay. Now I'm going to do this one over here as well. We get x equals -2, or we get that x squared minus 2x plus 4 is equal to 0. So we use the quadratic formula. We get 2 plus or minus the square root of 4 minus 16 over 2, right? So we're going to get that this is 2 plus or minus 2 square root of 3i, again, all over 2. So we're going to get 1 plus or minus 2 square root of 3i, right? Okay. The only thing that's changed there is your b value, right, is now negative instead of positive, right? So it kind of makes sense that we get a very similar solution. Okay. So over here we get x equals -2. We get 1 plus 2 square root of 3i and 1 minus 2 square root of 3i. Okay. So in total, we get 6 solutions, right? I like to write them as a solution set, but if you just put them as a comma delineated list at the bottom, or if you just went like this and this, that's fine too. I just like to write them out as -2, +2, -1 plus the square root of 3i, -1 minus the square root of 3i, right? 1 plus 2, oh, sorry. My 2's are supposed to cancel out over here. Nobody corrected me on that either. Okay, right. This 2 will cancel off with that 2 and that 2. Okay. So I should have that this is gone and this is gone. There we go. And then we have -1 plus the square root of 3i. Sorry, 1 plus the square root of 3i and 1 minus the square root of 3i. All right, there we go. So yeah, I like to put them as a list like that. Okay. Okay. So any questions on that? All right. So on to the next one then. All right, so now we have a radical equation, right? All right, so we need to somehow get rid of the radicals in order to solve this thing, which means we're going to be squaring both sides of the equation, right? I like for there to be only one radical on a side of the equation, right? Yeah, so since I have two radicals on this side, I'm going to move one of the radicals onto the other side, okay? So I'll just add the square root of 5 minus x to both sides. So I get the square root of 3 minus 2x will be equal to -1 plus the square root of 5 minus x, okay? And I'm just going to start off that way. Okay. And then now I'm going to square both sides of the equation. So I'm going to take the left-hand side and square it. I'm going to take the right-hand side and square it, right? So if I do that, on the left-hand side, I just get 3 minus 2x, which is not too bad, right? On the right-hand side, right, well, if I'm squaring it, then this is the same thing as -1 plus the square root of 5 minus x times -1 plus the square root of 5 minus x, right? And I got to FOIL it out, okay? Which is not that bad. So I get 3 minus 2x is equal to, well, -1 times -1 is +1, right? And then I get -1 times this, which will be minus a square root of 5 minus x, okay? And then I get square root of 5 minus x times -1, so it's minus another copy. So we get -2 times the square root of 5 minus x, right? And then we get plus the square root of 5 minus x times the square root of 5 minus x, right? Which is just the square root of 5 minus x quantity squared. So I'm squaring a square root, right? So since I'm squaring the square root, that's going to cancel off. And that's just going to give me 5 minus x there. So I have 3 minus 2x is equal to 1 minus 2 square root of 5 minus x plus 5 minus x. Okay. I'll pause here if there are any questions. Any questions at all? Yeah. That 2 square root of 5 minus x, right? So from FOILing this out, if I take -1 and I multiply it by this, that just gives me a negative square root of 5 minus x. But then now, if I take square root of 5 minus x and multiply by -1, then I get another negative square root of 5 minus x, right? Yeah, so that's 2 copies of negative square root of 5 minus x. Okay. Okay. So I'm going to combine some like terms here. 3 minus 2x is equal to 5 plus 1 is 6 minus 2 square root of 5 minus x, and then minus x, right? And then I still have a square root in there, right? So I want to leave my square root on the right-hand side of the equation, let's say, or I can move it on the left-hand side. It doesn't really matter. But I'm going to leave it on the right-hand side, and I'm going to move everything else onto the left-hand side. So I'm going to subtract 6 from both sides. I get -3. I'm going to add x to both sides, and I get a minus x, right? And then now, right, all that's left over on the right-hand side of the equation is -2 square root of 5 minus x. Okay? Fair enough. Now, I'm going to divide by -2 on both sides, right? Okay. You could leave it like this if you wanted to. Actually, if we did leave it like this, maybe it would save us a lot of trouble with fractions. Let's just leave it like this and let's square both sides of the equation. Okay. Yeah. So I'm going to square the left-hand side. I'm going to square the right-hand side. And let's see what happens. So on the left-hand side here, I have to FOIL this out. This is a -3 minus x times a -3 minus x. Okay. On the right-hand side, well, this would be the same thing as -2 squared times the square root of 5 minus x squared, right? Okay. So I can simplify that pretty easily. All right. So let's go with the left-hand side. On the left-hand side, I have, let's start with the x's. I have a -x times a -x, which is a positive x squared. I have a -x times a -3, so that's going to be a plus a 3x, right? And then I have another -3 times a -x, so it's going to be plus 6x. And then I have a -3 times a -3, so it's going to be plus 9. So that's my left-hand side of the equation there, right? Okay. On the right-hand side of the equation, -2 squared is positive 4, right? And then the square root of 5 minus x, we're squaring it. So we're going to get that the square root cancels off with the square there. And that just leaves us with 5 minus x. Don't forget to use parentheses. That 4 is getting multiplied all the way through. Okay. All right. So then now comes the part where we just clean it up a little bit. X squared plus 6x plus 9 will be equal to 20 minus 4x, right? Combine like terms. This is a quadratic equation, so you want to get everything over to the left-hand side of the equation. So we'll add 4x to both sides, so that'll be a 10x here. We'll subtract 20, right? So this will be minus 11 then, right? If we subtract 20. So we have x squared plus 10x minus 11 is equal to 0, okay? Fair enough. I suspect that that factors, right? Because we need two numbers that multiply together to be -11, but add together to be 10. I think we could do that. Yeah. So let's just find out. We want it to be a positive 10, so we probably want an x plus 11. Okay. And then x minus 1. So let's see if that works real quick. X squared, we get plus 11x, minus x is plus 10x, and then minus 11. Yeah, so that works fine. Okay. So we get two solutions then. We get x equals 1 and x equals -11. Those are our two solutions, right? Okay. Not quite done yet, but are there any questions so far? Okay. Any questions so far? All right. So then I'll remind you that with radical equations like these, it's possible to pick up extraneous solutions because you're squaring both sides of the equation. And by squaring it, it ignores negative signs, right? Everything squared is a positive number, right? So you could wind up with something that doesn't make sense in the original equation. You got to check them both, okay? So let's start off this way. Let's check x equals 1, okay? Let's check x equals 1. I got to scroll up for just a second so I can remember what the function is here. We have a square root of 3 minus 2x, right? So square root of 3 minus 2x minus a square root of 5 minus x equals -1. Okay. And we're going to be plugging in x equals 1 into this, right? So if we plug in x equals 1 over here, I get 3 minus 2 is just 1. So square root of 1 is just 1. Minus, here we have a 5 minus 1 is 4. Square root of 4 is 2, so we get -2 equals -1. That checks out, right? So x equals 1 definitely works. Okay. Any questions on that? Okay. All right. Well, then now let's check x equals 11. Or sorry, -11. So if we check x equals -11, right? We're plugging it into the same function over here, right? I'll write it down again. Okay. So if we're plugging in 11 over here, we get 3 minus 22, right? 3 minus -22. So that's going to be a square root of 25, which is just 5. Okay. And then over here we get 5 minus negative 11. That's 5 plus 11, which is 16. Square root of 16 is 4, right? So we get 1 equals negative 1, which is definitely not true, right? Fair enough. 1 does not equal to negative 1. So then we get only one solution. Oops, not that one, the other one. Okay, this is our final answer. Okay, that's the only solution we have. Oh, yeah, that would be good. Yeah, so check x equals 1 and then, plug it in and see that it works. Check x equals negative 11, plug it in, you see that it doesn't work. Yeah, yeah, so try to present it in a very similar way. Yeah, okay, yeah. And remember, if you're ever questioning, like, did I show enough work or something like that, or should I say more? Think about it this way. When you're trying to show your work on the exam, try to show your work in a way where another college algebra student can understand what you're doing. Yeah, fair enough. They should be able to look at your paper and say, okay, I see how you got here, and I see why you got to this next step, basically. Yeah, okay. All right. So this is the last problem on the exam here, right? And this is one of those transformation problems, right? Okay. So let's see what we have here. We have A is equal to negative 2. B is equal to 1/2. C is equal to negative 2, right? If you see a plus sign on the inside, that means your C is negative. Yeah. If you have a minus sign on the inside, your C is positive, right? It's backwards, right? And then your D is negative 1. Okay. So that's our A, B, C, and D there. Okay. So I labeled this A through E over here, right? So there wouldn't be any confusion about which operation you should do, right? Yeah. So in part A over here, I want to see you do that horizontal shift on the graph right over here, right? So here we have C is equal to negative 2, right? Which means that you're going to have a horizontal shift, right? 2 units to the left. Okay. 2 units to the left. So each one of these points that we have over here, lost my mouse there. Each one of these points should get shifted 2 units to the left. Okay. So this point over here used to be at x equals 0. Now it's going to be over here at x equals hold on. This thing is frozen. There we go. Okay. Here at x equals negative 2. Right. This point used to be at x equals 1. Now it's going to be over here at x equals 0. Right. This point over here used to be at x equals 2, but now it's going to be over here at, oh, sorry, 2 units to the left. Sorry, x equals negative 1. My bad, everybody. There we go. This point used to be at x equals 2, so now it's going to be at x equals 0. This point used to be at x equals 3, so now it's going to be at x equals 1. This point used to be at x equals 4, so now it's going to be at x equals 2. And then now I'll just connect all the lines, like so. And there's my graph that has been shifted 2 units left. Okay, fair enough. Any questions on that? Any questions at all on that? Okay, so now I don't need to look at the original graph anymore. I need to look at this graph when I do my next few transformations. All right, the next one I want to do is my horizontal stretch. Okay, so my horizontal stretch is determined by what my B is, right? So I abbreviated this one as HS for horizontal shift, but now I have a horizontal stretch. So maybe I'll do that as HST or horizontal stretch. I don't know. Yeah. So remember that the horizontal stretch is always you're multiplying by 1 divided by B, right? 1 divided by B. So that would be 1 over 1/2, which of course would just be the reciprocal, which is 2. So each of your x coordinates is getting multiplied by 2. Yeah, fair enough. Each of your x coordinates is getting multiplied by 2. So I'll write down here horizontal stretch, right? And it's going to be stretched by 2. Right? And that's a factor of 2, right? So over here we had an x value of negative 2. Now it's going to be at x equals negative 4. Okay, because it's getting multiplied by 2 there, right? Over here we had an x value of negative 1. Now it's going to be at negative 2. Okay. Over here we had an x value of 0, right? So then that times 2 is still 0. Okay. Over here we had an x value of 1. Now that's getting multiplied by 2. And then over here, we had an x value of 2. Now it's getting multiplied by 2. Okay, so that's what it looks like. Everything has been stretched by a factor of 2. Okay. Any questions on that? Any questions? Okay. No questions? All right. Well, then we'll do our vertical stretch then, right? Okay. So the vertical stretch, V stretch, right, is we're multiplying by whatever the absolute value of A is, right? So this is going to be stretched by a factor of 2. Okay. By a factor of 2. Okay. Don't worry about the negative sign out front. That corresponds to a reflection, which we'll do on the next step, right? Okay. So we're going to stretch all of this by a factor of 2. Okay. So over here, I'll write for vertical stretch, stretched by 2. Okay. Any questions on that? All right, so all of our y values are getting multiplied by 2. So here we had a y value of -1, right? So now it's going to be multiplied by 2, so that's -2. Right, here we had a y value of -1, so now it's going to be multiplied by 2, so we're going to be over here at -2. Okay. Right here we had a y value of 0, so that times 2 is still 0. Okay. Here we had a y value of -1, so that's going to get multiplied by 2. And then here we had a y value of 0, so that's still going to be 0. Okay, so all of our y values have been multiplied by 2. Okay. Any questions on that? Any questions at all? Oh, sorry. Probably still copying that down. Yes. Yeah, the y values, right? Because we're doing a vertical stretch, right? Yeah, so it's the y values that get stretched this time, right? When I say horizontal stretch, it's the x values that are getting stretched, right? Yeah. Yes. Yes. Yeah. Yeah. So I want to see each one graphed sequentially like this to wind up with your final answer. Yeah. Okay. Yes. Oh, you multiply it by the absolute value of A, I should say, right? Yeah. Same thing with your B. If your B was a negative number, you would be multiplying by absolute value of B for the horizontal. Sorry, absolute value of 1 divided by B for your horizontal stretch, right? Yeah. Yeah. All the reflections are going to happen in part D here, right? So, okay. So then now let's look at the reflections here. So like we noted before, right? We have a negative sign on our A over here, right? So that's going to correspond to a reflection over the x-axis, right? You're going to flip it upside down, right? That's a reflection over the x-axis. Yeah. So over here under reflections, I'm going to write reflection x-axis. Okay. And so all of my y values are going to flip over the x-axis. This was a y value of -2. Now it's going to be over here at +2, right? This was -2. Now it's going to be at +2, right? This was 0, still 0, right? This is going to flip over to be +2, right? And this is still 0. Okay. Any questions on that? All right. And then the last thing that we do is the vertical shift, right? So here we see that D is equal to -1, right? So that's going to mean that we have a vertical shift down by 1. Yeah, down by 1. Okay. So all of my y values are going to go down by 1 then. Okay. So I'm going to write over here under vertical shift down by 1. You can just say down 1. That's fine. So here we had a y value of +2. Now it's going to be a +1 here. Same thing with the next point there. Right. Here we had a y value of 0, so that's going to be at -1, right? Here we had a y value of 2, so now it's going to be at 1. Here we had a y value of 0, so now it's going to be at -1. And so my final graph looks like this. And so that is the completely transformed graph of g of x there. Okay. Any questions on that at all? Sorry. Bugs in the room. Yeah. Sorry. So if D was positive, right, then that would mean that we would shift up by a certain number of units. Is that what you mean? Oh, so you mean part D over here. Okay. So if our B was a negative number, yeah, then you would flip it over the y-axis. Exactly. Yeah. Okay. Yeah, if our B was negative. Okay, yeah, I was like, man, this thing is just like raining down over here. Well, that doesn't look healthy. We're gonna wind up with like black mold in our lungs or something, man. Yeah. Well, it's a good thing that I'm done with the practice exam then, because yeah, we should probably all just get out of here. Yeah, I'm gonna put in a, a request to get this thing fixed before our exam Thursday. If you do have any questions, I'll head back to my office if you want to follow me. Yeah. So.